Okay, welcome everyone. Let's give 1 minute for everyone to join in and then we can get started. Okay, let's get started now. I think we have people joining in. Hey everyone, welcome to the session. My name is Richa. I am a software engineer. I work primarily on the backend systems. We will be learning about system design and how the system design interviews are conducted, how you should approach the interview. We'll be learning about all of this in this session, and also we have few more sessions planned for you that I'll be talking about later. So we'll be learning about all the system design interviews, everything about the interviews end to end in these few sessions. I have personally been on both sides of the interview. I have been an interviewee as well as an interviewer for the past few years. I have had a lot of learnings along the way, so I'll be sharing all of that in these sessions. This will also be helpful for a fresher who is just starting off, and as well as someone who is experienced. So both of these audiences can learn a lot from these sessions. So let's get started. We'll first talk about a bit about the plan of the different sessions that we have planned out for you. So we have 5 sessions in total. Today, which is the first session, we'll talk about the fundamentals. This will be a very light session where we'll talk basically about how the system design interviews are conducted. We'll talk about like a breakdown of the system design interview, how to approach these interviews. So basically, like the initial steps of the interview, whenever you have a question thrown at you, how should you get started? That's what we'll talk about in today's session. In the second session, which is the high level design, we will talk about high level building blocks of any system. It can be like a database, a caching mechanism, a load balancer, or any of those high level building blocks that are part of any system design. In the session three, we'll dive into the low level design. The low level design, it's primarily about the system design patterns, UMLs, and other low level blocks of the design. In the session four, we'll talk about some advanced topic like Kafka, messaging queues, Zookeeper. We'll dive deeper into some popular databases that are out there that are used in some real world systems. So these are essentially pretty much the overall framework of a system design. In the last session, we'll talk about some real world systems. This will be basically everything that we learn in the first 4 sessions will everything will come together. It will be similar to it will be very close to an interview setting, and we'll see how basically you put everything that you have learned in these sessions, put everything together, and how you actually perform in a system design interview. So today's session will be starting off with the first topic, which is the fundamentals. So before getting started, I see there are a lot of questions being posted. So at any time, like feel free to post your questions that you may have. We'll also have a Q&A section at the end where I will take all these questions, and I'll also try taking the questions in between. But don't worry if I don't take them up right now. I will also take them up towards the end of the session. So let's get started. Yeah. So before starting off with the fundamentals, I want to break down how the system design interviews are conducted. So this is essentially a framework for approaching a system design interview. Uh, this is a general rule of thumb. However, you are not binded to stick to it. You can also anytime feel free to modify this framework as and when you get more familiar with the system design interviews, you can feel free to move things around according to what you have learned from your experience in the interviews. But to starting off, I think this is a good framework to keep in mind in your, at least in your initial few interviews. So, also, I would like to point out, unlike a coding interview, a system design interview is driven mostly by the candidate. So, once you are in the interview, the interviewer can start off with, let's say, a generic question, let's say, design something like a WhatsApp system. So, it is a very vague problem statement where that's when like the candidate comes in, and you basically have to cross question the interviewer and get the minute details of the system that will help you in your later section of the interview to understand basically the intentions of the interviewer as well, like what the interviewer wants you to focus on. Obviously, like a WhatsApp size system, it's impossible to design in an hour long interview. So what will happen is you have to cross question the interviewer and get an idea what exactly the interviewer wants from you. Especially, I think in the initial, let's say for a fresher, they might not expect you to dive deeper into a lot of these components. So they might be okay with you going on high level with pretty much all the services that are being used in the system. As and when you are experienced, they might ask you to go dive deeper into a few of those services that you have provided in the high level design, and then you discuss like details about those designs. So this is also a sequential framework. So let's say first step is the requirement clarification. So let's say you cross question the interviewer, get a clear idea of what the interviewer wants, and you, at the end of the step one, you will have a set of requirements that you have noted down. So all this while, once you ask, when you are asking the interviewer, you are also noting everything down. So you will have a list of requirements at the end of step one, where that will serve as a blueprint for you to basically, as a, also as a starting point for you to dive into the other steps of the interview. And those will also serve as like the base of how the rest of the interview would go. So it is also a very critical step in the interview process. The second is the capacity estimation, where so all of these are sequential. So the output of one step goes as the input for the next one. So once you have your requirements, you based on the requirements that you have collected, you go forward and estimate the capacity. So capacity is can be something like, let's say, how much data storage that you want for the system. So based on the requirements that you have clarified, you would have some numbers, and based on those numbers you can estimate maybe some GBs of data would do good, or you might need some more terabytes or even higher amount of storage. So essentially, you do a rough estimate of those numbers, and that's what you present to the interviewer. And if everything looks good, that's when you proceed to the next step, which is the system interface definition. So here what happens is, let's take the same example of WhatsApp. So you have a WhatsApp application. So once you, let's say, you send the message to your friend. So what happens is it calls an API to the messaging service, and the messaging service then takes the message and sends it uh, to the required recipient. So this happens over an API service. So as part of this step, you would have to discuss how these different services will talk to each other. So, messaging service is just one service. There can be like tens or even more number of services in the system. So, here you would have to define how these services talk to each other. Mostly it's through APIs. So, here you would define like what the input, what the output for the API should look like. So that's very brief about this. Then in the step four, we talk about the data model. So here we talk about, let's say, essentially it's between like, would you go for a relational or non-relational database? There is no right or wrong answer for this. So you essentially, based on the requirements that you have with you until now, you propose like why would you go with one over the other. Let's say you want to go with a SQL database, you would propose that I would go with an SQL, and why would I go with an SQL. You will also discuss the trade-offs of why one over the other. The next one is the high level design, where again all of these different pieces will come into picture, where you would define like what are the different services that you have. You might have, let's say, 5 to 10 different microservices that will come into the picture. So you will, on a high level, you will define all those microservices and lay down a blueprint, basically a rough diagram of where you'll place all of these services, how you'll have a client, you'll have a database, you'll have a cache. So all of these will come together in a high level design. Now, in the next is the detailed design, where you can also ask the interviewer if they want you to go into detail of based on the time you have in the interview. They can maybe ask you to dive deeper into one or more services in the system. So make sure you ask them that, and based on that they will tell you, like, okay, let's go dive deeper into the messaging service, and that's when you dive deeper into that and you talk more about how the design for that microservice will look like. And the last step is essentially, this is not uh, a step at the last, I would say, where basically you identify and resolve the bottlenecks. So you, all this while, you keep discussing about the trade-offs of why you prefer one over the other, or like why you prefer your design over something else. So before proposing your design, you also would lay out, let's say, 2 or 3 different options, and based on those options you might discuss the trade-offs and why you would go with one design over the other. So all of this would essentially be happening through all these different steps. And even in the end of the detailed design, let's say you, there might be some bottlenecks in the system, or you want to discuss more about the trade-offs uh, based on the decisions that you have made previously. So you can feel free to do that towards the end, or you can also do that while you are uh, basically at the end, or while you are in any of these steps. So this is the framework. Let's go to the next one, which, so we'll start off, sorry, in today's session we'll talk about the first two, which is the requirement clarification and the capacity estimation. This is going to be a very light session, I would say, not a lot of technicalities, because the initial steps are more about framing and setting up the stage for later half of the interview. So the coming session that we have planned for you, which is the rest of the 4 sessions, will be more heavy, will be more technical. So let's start with the first step, which is the requirements clarification. So the design questions are mostly open-ended. They don't have one correct answer. First step in approaching a system design problem is to thoroughly understand the problem statement. So as I mentioned before, pretty much all the system design interviews are open-ended. When you are given a question, it's basically can be a vague or a black box kind of situation, where they'll tell you, let's say, design an X type of system, and that's it. Like, they wouldn't provide you all the ins and outs of the system. So that's where you will come into the picture. You will ask them all the questions. So, and so based on how you ask the question, it will also basically help you scope out the systems for the later part of the interview. So also, understanding, the third point here is understanding the scope early prevents you from heading in the wrong direction. Given that the problem statement might be vague, uh, what can happen is what you interpret uh, from the question might not be the intention of the interviewer. So basically, asking as many questions as possible, and also being asking the right questions is the main idea. So that will help you set the tone and basically walk towards the right direction and not sway in the wrong direction from the starting. So best way to clarify these requirements is to ask relevant questions. By asking relevant questions, the candidate demonstrates not only their technical knowledge but also the problem solving approach, ability to think critically about the problem at hand, and attention to detail. So this is very important. So based on the questions that you ask, like Let's say if we compare to a coding interview, there also you once you have a coding question given to you, you are expected to ask questions. Compared to a system design interview, here you are expected to ask more on I would say compared to a coding interview, you are expected to ask more questions. Definitely, that is the case. But also, the question that you ask also tells about your credibility, your problem solving skills, and how much attention to detail you're paying on these small pieces of the system. That will play a huge role in not just setting the tone for the rest of the interview, but also leaving a good impression on the interviewer. So let's get started to the next part, which is how do we clarify the requirements. So here I have listed down a basic example. Let's say I'm taking the same example for WhatsApp. So what can happen is, let's say an interviewer asks you to design a WhatsApp-like service. So here pretty much most of you have been using WhatsApp or are familiar with what WhatsApp is. Uh, there can be at times where the interviewer asks you to basically talks about a service, design that service, an X service where you don't know about the service. So it's totally okay to for you to jump in there and basically ask the interviewer to explain to you what the system looks like in a few sentences. So let's say if you don't know what WhatsApp is, the interviewer might be able to provide you, let's say it's a messaging based service where you can message your contacts in real time. It can be a one-on-one setting. It can also be a group level messaging. So if you don't know what WhatsApp is, feel free to ask that before jumping into the next part, which is clarifying the requirements, because unless you don't know what the system looks like, it will be difficult for you to come up with the right questions. So don't hesitate to ask more about the system if you don't know anything about that first. So once that is set, what you can do is these are the sample questions that you can ask. Let's say first question is, what kind of app should we design? Should it be a one-on-one or a group-based application? So you can just ask this to the interviewer. Interviewer can reply you back with, let's say, let's just design a one-on-one, or we should have both the functionality in the system. So it totally depends on what the interviewer wants you to design. So this is like one sample questions that you can ask. The other one is this a mobile or a web app or both? So again, it's a very basic question that you could pretty much use in any interview. The third one is, how many users should we support? Let's say I have listed down a few metrics here, like total users or daily active users. It helps you set the ground for the rest of the interview, where you are able to gauge the number of interviewers, basically the scale of the system that you're catering to. So let's say if it's a new application, it can be, let's say, 100 or thousands of users, or a WhatsApp like service can have millions of users. So it's important to understand what the user base looks like. The fourth one is, what features are important for the app. For example, one-on-one chat, a group chat, online indicator where it shows you when your contacts are online. There is also a notification where, let's say, if you're off the app, you are sent a notification when you receive a message. So it is just not limited to these four features. There are other features as well in WhatsApp. So what you can do is you can start listing out these features. There can be pretty much, like, let's say, more than 10 features on the app. Again, it's not possible to cover all of these features in an interview. So you can also follow up this question with uh, which uh, which features do you want me to focus more on in the interview. So let's say user can start off with, like, sorry, the interviewer can say, let's start off with one-on-one and group chat first, and then if we have time remaining, we can focus on the online indicator and the notification part. So this is what a generic response from the interviewer would look like. Then the next question is, what types of messages do we support? So it can be a text message, it can be an audio, video, Again, the size of the message will change based on what types of messaging we are supporting. So it's important to ask because this will help you determine what size of database you need. So make sure you ask uh, questions related to data and data sizes and database sizes. And the next one is, let's say, do we need encryption? So WhatsApp supports encryption of your messages. So you can also, this could be one sample question. The last one here is how long we should store the messages. So let's say a WhatsApp like service pretty much has a historical storage, so it stores all the messages you have since the inception with the with your let's say with your friend. So again, based on how long you store the message, let's say you store the message for a 1 year, or you want to store it for 5 years, or you want to store all the messages, the size of the database would change accordingly. So it's also a good question to ask. So this is just a sample question. You can think of maybe 5, 10 more questions that you might have. You should ask all of them in the beginning to clarify more about the requirements. Now, will that was an example. Now we'll dive into more structured approach to this question. So there are two types of requirements that you should aim to clarify. First is the functional, and the second is the non-functional requirement. So the functional requirements are about the core product features and use cases that the system needs to support. So in the same example, like WhatsApp, let's say what happens is the core features can be anything like, let's say, a messaging. You want to send users a message, you want to send users notifications. So these are like the core messages of core features of the system. So this can be termed as a functional requirement. The next one is the non-functional requirement, where we talk about the system's performance and the quality attributes. So let's say in the same example, um, WhatsApp supports a real-time messaging service. So what happens is here it's extremely critical that the latency for the system should be as minimal as possible. There can be systems where it's okay if the messages are delayed for a few seconds, let's say a few milliseconds to a few seconds. So that totally depends on the system that you're designing. So that's what is a non-functional requirement. The next one is we talk about the input. This is just a framework where, as I mentioned before, like the input for this would be the problem statement that is given by the interviewer, and the output would be list of functional and non-functional requirements. Now we'll dive deeper and more into the functional requirements. So, uh, as part of this requirement, you focus more on the what. You all of the questions that you ask are more about more like starting off with what and followed by the question. So this is a framework. This is not a hard and fast rule that you have to stick to this. This can be a good starting point, and as in you start with more participating in more interviews, you can have your own set of framework that will be a go-to questions that pretty much work with most of the different systems. And then there will also be set of questions that cater to some specific set of systems. So again, these are very basic questions like what are the core features of the system. In WhatsApp, it was like message, notification, online, and all of these are the core features of the system. Second question is what features are more critical than the others. So again, based on the time that you have, maybe the interviewer can tell you, let's focus on one or two of those features, and if we have more time, we can dive deeper into other features. Next is who are the users. So in WhatsApp, let's say the customers are the users. There can also be products where, let's say, it's an enterprise tool. So like an internal team would be the user for that system. So based on who the end users are, uh, it will also be a good starting point to clear out the requirement. Next is what action should users be able to perform. Again, in WhatsApp, let's say you are able to send message, you are able to bookmark a message. um, you can delete a message. So these are like the actions that users can perform. These are some of the actions. So you should have APIs defined for all of these actions. So it's good to clear what set of actions the user can perform. Next one is how will user interacts with the system. Again, it can be a web or mobile app, or it cannot be an app at all. It can just be exposed through an API. Mostly in, like, let's say an internal system, it might be just have an API based interface and not particularly an application. Next one is what are the key data types of the what are the key data types the system must handle. Same as text, images, or a structured data. This will help you choose in uh, in the next steps of the interview. This will help you choose if you want to go for a structured, a relational database or a non-relational database based on the types of data that the system is handling. uh, Again, the last one is, are there any external systems or third-party services the system needs to integrate with? So let's say, if I have to give you an example, let's say WhatsApp has a notification service. So WhatsApp, given that it's a pretty large scale application, it has its in-house notification service. But let's say if it's a small scale application, they might not have the capacity to develop a notification service in-house. They might use a third party. There are a lot of like service providers, internet service providers, that provide these services. So a small scale application can integrate with like a third party notification service and leverage their functionality to deliver notifications. So it's also good to make use of, like, ask these questions to figure out which of these services uh, can you basically be a good point to integrate with the system. And also you can, we'll also talk about more on this later, but it's also good to have like few of those examples of the third party services. Let's say I gave the example for notification service. So let's say if you want a text message notification, so there is an iOS, there is an Android application. So both have their different sets of third-party services that provides an iOS application, iOS notification, or an Android notification. So it's good to have some of those names in handy. So it just, you can leave a good impression with uh, leave a good impression with the interviewer when you have accountability of those services. Let's move to the next, which is, so these were all about the functional requirements. Hope that is clear. Next, we'll focus on the non-functional requirements. So non-functional requirements, as we discussed before, it's mainly about the quality of the system. So we'll focus on key characteristic like availability, reliability, scalability, cost, efficiency. So if you don't know any of these, we will also dive deeper into in a few minutes. Uh, Here it's important to, just one point which I would like to highlight before diving deep into those is, it's all about trade-offs. So let's say a system can be highly available, highly scalable, highly reliable, but it can again come at a high cost. So it's good to talk about the different trade-offs here, so you can understand what the interviewer wants you to focus on. For a system, it might be okay. For let's say a particular system, a WhatsApp Lite system, they want it to be highly available. So it's okay if this increases their costs, but a different system might not focus more on the availability. They are okay with, like, let's say being, let's say have like a few seconds of downtime, and it comes with like a low cost, so they are okay with the trade-off. So it's important to clarify the trade-offs here in the non-functional requirement also. So we'll talk about the first non-functional requirement, which is the scalability. So what is scalability? Is the capability of a system, process, or a network to grow and manage increased demand. So any system that can continuously evolve in order to support the growing amount of work is considered to be scalable. So let's say we use the same example of a messaging service. So a service that is just starting off might just have like a few hundred to a few thousands of users. Like a WhatsApp like messaging service obviously has millions of users. So the user base can range from 100 to millions of users. So it's a pretty large range. So let's say you might start off with supporting a few hundred or a thousand user. And as and when your application becomes popular, you have more users joining in. So you want to make sure your system scales with the increasing user base. And let's say, what if like your user is only your application just supports like 100 to 1,000 user base, and when you have more users coming in, your just system, the application just crashes. So we don't want that. So you want to scale the system accordingly. So there are two types of scaling approaches. The first one is the vertical scaling, and the second is the horizontal scaling. So you can look at the picture here. The first one on the left is vertical scaling. So based on the picture, you can see we have like a small server, and then the size of the server increases. So here, what happens is we just add more resources to the same server. So we can add more CPU, we can add more memory, we can add more. Basically, yeah, we just add more memory and CPU to the same server, and that can basically cater to growing user base. The one on the right is the horizontal scaling, where you can see the size of the server does not increase, but we add more servers. So we started off with one server, and then we have two, three, four number of servers. It can also keep growing with increasing user base. So there are also trade-offs for these two types of scaling. So the first one, the vertical, there it comes with a limit. So you can't just keep adding resources to a same server, and just you can't keep doing that indefinitely. There is a limit on the maximum number of resources that can a server handle. So that is one drawback for vertical scaling. For horizontal, you can let's say you start off with 5 servers, and you see that your user base is growing. You add the sixth server, you add the seventh server. So basically you scale it like as you go. You also have like load balancers attached, which helps you uh, distribute the traffic across all of these services. So we'll talk about load balancer not in today's session, but in the second session. So that's all about scalability. The second is the reliability. So reliability is a probability of probability a system will fail in a given period. So then what's a reliable system? A system is considered reliable if it keeps delivering its services even when one or several of its hardware or software components fail. Um, so unlike availability, here what happens is we even if something is failing, even if let's say one of your services is down, we don't want the whole of the system to be down. We want the system to be behaving as if nothing is wrong with the system. So what's the solution for this is redundancy. Let's say in WhatsApp, you have a messaging service. So you don't want to just have one service that handles the messaging part. You might want to have redundant servers. So let's say there's a primary server that takes care of it, but once it goes down, there's something wrong with it. Unless it's able to recover, you direct all the traffic to a secondary server that actually does the same job. So for someone who looks at from the outside, nothing has changed. So that's what reliability looks like. If you look at the example, um, we have like 4 servers here. So this is what reliability essentially means. So you would, let's say the diagram does not say it, but let's say one of these server might just be the primary server, and all of the traffic just goes through that. And once, let's say the first one is down, it communicates to the secondary server, and lets it take the rest of the functionality of the system. Unless now, when the second server is performing its job, that's when the first server, we try to recover that. And once that is recovered, then all of the traffic goes to the primary server. So that's what reliability. It also comes with a cost. So like you cannot uh, just keep adding, let's say a messaging service, you can't have like 5 of them. Obviously it comes with a cost. So usually there is a primary secondary system where you have 2 services in the picture, and once the primary fails, the secondary comes and takes its place, and while the primary is on the recovery mode. uh, they might scale these services, like some critical services might be scaled or redundant beyond uh, to service. So that also depends on how critical the system is. So this is about reliability. We'll move on to the next one, which is availability. So availability is time a system remains operational to perform its required function in a specific period. Availability is also a simple measure of the percentage of time a system, service, or a machine remains operational under normal conditions. A system without much downtime can be said to be highly available. So again, it's like a pretty naive and clear based on the definition here that we want the system to, like, you would have heard a lot of these large scale system going down, so that is when the availability goes to zero. So we don't want that to happen. We want to the system to be fully functional and available, doing all its functionalities all the time. So usually that's what we should aim for, but then things happen, services go down. That's when, like, we the availability completely goes down and we try to recover those systems. Now, one thing to note here is, let's say, you can often tend to confuse between reliability and availability. So it can happen. Let's say if we read here, it's if a system is reliable, it is available. However, if it is available, it not necessarily be reliable. So let's say WhatsApp. So you are sending a message on WhatsApp. On the back end, what happens is they also store these messages in their database. So let's say the system is available, you are able to send the message, but the message is not getting stored in the database. So what is happening? It's losing out on those messages. So here it's available, but it's not reliable. So this is one such example where from the outside you see that it's available, but you're actually losing on those messages. So the reliability goes down here. So again, it's all about trade-off, which you want to focus more and more on the other, depending upon the system use case. The last one we'll talk about is the efficiency. So there are two standard metrics to measure the efficiency. The first is the response time, or also called latency. It's the delay to obtain the action, delay between the action and the response. So again, in WhatsApp, it's pretty much real time, so latency is as minimal as possible. It can be maybe a few nanoseconds. So you send a message and your contact receives the messages almost in real time. So it has a good response time. The second one is the throughput or the bandwidth, so which means the number of items delivered in a given time unit. So it can be for a messaging service. Let's say if um, a service has a certain limit on number of messages that you can send. So WhatsApp does not have, but let's say if a service is not able to support thousands of messages, they might have a bandwidth on number of messages you can send. Let's say it might say you can only send 5 messages a minute. So it can be bandwidth can be a limit for, let's say, a small scale messaging service. So this is all about non-functional requirements. Here again, I've listed down the framework here that you can use for the non-functional requirement. Again, it's a generic framework. You don't have to stick to it. You can keep adding things to it, keep modifying it as you go. So the first one is, what is the expected scale of the system in terms of users and requests? Um, let's say how many users, how many requests, like how many messages you're supporting in a particular second or a minute is what um, means by this question. The second is how much data volume is expected to be handled by the system. It's again very basic question. Then what are the inputs and the outputs of the system? This more caters to um, helping you understand the API design. Let's say what kind of let's say you discuss about what kind of messages you want to support. So based on that, your API design will change. So it's good to talk about the input and output here. Um, so the next one is, what is the expected read to write ratio? So what this means is, let's say WhatsApp might not be a good example here. Let's say I talk about we can take an example of let's say food delivery app. So you go to the app, you search for restaurants in your area. So here what happens is you put in your area, there is you set a radius, let's say in 5 kilometers, 10 kilometers, and it lists out all the restaurants in that area. So this is a read heavy system. So there will be thousands of user, if not more, reading every second. Basically every second they will be generating this query. So the read would be way higher compared to write. Write is where, let's say, a new restaurant is being added to the system. That's where the write comes in. So a new restaurant might be added. Maybe like there are 50 or 100 restaurants being added once a day. But then the read response, it's maybe more than thousands of queries every second. So the read would be way heavy compared to write. Then the next one is, what are the latency requirements? Again, if do you want it real time, or is it okay to have a few seconds of lag? That's a good question to ask. The next one is, can the system have a downtime, or does it have to be highly available? Again, it depends on the system. The interviewer will tell you what he would prefer. And the last one is, are there any specific non-functional requirements, performance, scalability, reliability we should focus on? Again, this is pretty much similar to the last one, where you talk about the trade-offs. So there are n number of things a system should focus on, but then it all comes to the trade-off, what you want to focus on and what not. So that's where you ask the question and clear everything about the system. So that's essentially about all about clarifying the requirements. So by end of, I think this is the last, yeah. So by end of all this, you should have listed down all the functional and the non-functional requirements. So you should have two sections, let's say whatever in the interview, whatever UI you are using, but you should have listed down, okay, these are my 5 or 10 different functional requirements and these are my non-functional requirements. So it should be right there in your screen, and that would be a starting point for your next step. So the next step, if you remember in the framework, was a capacity estimation. So let's move on to that. Yeah. So it's also about scoping out the requirements that we have gathered initially. It's also called capacity estimation. Here, what we do is we estimate the scale of the system that helps you make the design decisions. Uh, it ensures that the system can meet the desired criteria. It can also account for the future growth. So let's say if you're designing a message based service, you can start off by saying, okay, I will design for uh, a low scale application. Let's say my user base might just be 1,000 users, and I will scale it later to accommodate maybe, let's say, 10,000, a lakh, a million users accordingly. So that's where you should scope out all of these requirements, so that the interviewer and you are on the same page. Um, I will take an example for this. Let's use the same example for WhatsApp. So here, let's say this is how essentially you estimate things. So you also have to estimate on a very high level. Don't go and dive. Don't focus on the calculations here, because there, if you start focusing on those, it might get tedious. Like, you don't have to use a calculator here. It should be a very basic math. So there are, you can see a lot of numbers. Let's say always you can, if there are you should tend to like round off numbers here. So let's first start with the how we start the estimation. So let's assume that we have 500 million daily active user, and on an average each user send 40 daily messages. So this is the premise of your capacity estimation. You can start off with something like this, and the user can and the interviewer can tell you, okay, yeah, this feels like a good starting point. It's okay, we can consider this as an assumption, and based on this we will uh, estimate. And if the interviewer is not happy with they might ask you to change these numbers a bit, and that should be okay. Then if there are 500 daily active users and then there are 40 messages, so we have about 20 billion messages per day. uh, Then we have a storage estimation. So here, let's assume that on an average, each message is 100 bytes. So to store all the messages for one day, we would need 2 terabytes. So again, yeah, here it's a very basic calculation. It shouldn't be a problem. Now, for these 2 terabytes data per day to store for 5 years, we would need about, again, it come here, it says 3.6 petabytes. You don't have to do that. You can pretty much round off, let's say 365, you can round off to 400 or 500. It should be totally fine. That's not a problem. So tend to round off all these and don't get into the actual calculation. So it doesn't matter for you to, it's not required for you to get the exact numbers. So you should just round things off when necessary. Um, so yeah, this is about the storage estimation. We also have the bandwidth estimation. So if our service is getting 2 terabytes of data every day, this will give us 25 MB of incoming data for each second. So it's just terabytes divided by second. Again, here they have used 365 into 24, I think. No, 24 into 60 into 60, which is this. So you don't have to use that. You can just round it off to 100,000 and that should be totally fine. So it comes out to 25 megabytes per second. Then we have, since each incoming message needs to go to another user, we will need the same amount of bandwidth, which is 25 megabytes per second for upload and download. So this will serve as a premise for you to determine your next steps, which, let's say, which is a high level design where you talk about the databases. So the scale of the data will help you determine if you should go with like a relational or a non-relational database based on how much size of data you need to support. So yeah, so essentially, like the framework for this would be, you start off with an assumption, which here is 540, and then you find out the storage and the bandwidth estimation. So sometimes this, even for me, initially the calculations would get tricky. So the only thing here you can do is you can just while you are practicing, while you're reading for the interviews, you can just practice these numbers, and it has to be as high level as possible. You don't have to get to the exact numbers. um, there's some tips for, yeah, I think this is the last topic that we'll cover. So it's you just have to practice the calculation. So while you're practicing, you will come with tips and tricks here and there that will help you perform these calculations faster. You can also have a note of all of these on the side that help you get fast with calculations. This is one such which I tend to use, which is uh, we use store data in terms of bytes. So I think having the power of 2 handy is good. So here you can see like 2 power 10 will approximately be 1000, and it can be rounded off as, it can be rounded off to 1000, and it can be a kilobyte. Same as 20, 30, 40, 50. It can be a kilobyte, a megabyte, gigabyte, terabyte, and petabyte. So these are again rough numbers, and these are like work best for the interviews. You don't have to get to the exact number. So this is just one of the many calculation things that you should have in your memory. As and when you start practicing, you will also have more of such tips and tricks handy with you that will help you calculate things faster. Yeah, so this was the last topic that we were gonna talk about, and we'll have the Q&A section now. So feel free to post your questions, and I'm gonna look at the chat and share my inputs there. I think somebody asked, is system design required for automation testers or in the interview process? I'm actually not sure. I have not appeared for a like I have mostly appeared for a developer interviews. So I'm not sure if it is required for automation tester interview or not. Um, the second one is, this is for aspiring SE students, right? Yeah, so this will we will have, let me pull out the session plan. Yeah. So this is the plan. We covered the day one today. So this is catering to anyone, a fresher who is just starting off, also to somebody who has been around for a few years, who is experienced. Just what happens is just the depth of these interviews changes. So let's say if we are heading to some advanced topics, it might not be asked. Usually, it's not the focus of somebody who's a fresher. So yeah, so you can. It's good to know about the topics, but you, as a fresher, you might not dive deeper into that. But somebody who is experienced might have to learn about some advanced topics as well. Also, these totally depends on, like, you can start appearing for interviews and you feel that what you know is good enough for the interview. That's how I do it. Like, I didn't start off with learning from zero to till advanced topics. I learned a bit, and then I would also do interviews and see how I am performing. If I need to learn more about the systems, if I need to go dive deeper into these systems, then that's when, like, you go back. It's a feedback mechanism there. Next question. Is this much content sufficient to crack interviews? Okay. So for these 5 days, we'll have an hour-long session every day. So pretty much we will have 5 hours to ourselves. So it's not sufficient to cover for me to cover all the topics. So what I'm gonna do is I will try to for the next sessions, let's say for the high level, I will cover a few topics in as much as I can in the session, but I will also list down a few topics at the end which I'm not able to cover, so that you can go back and read more about that topic. So essentially, like, whatever we covered as well today about the requirements and the capacity estimation, you'll have a lot of resources online as well. So let's say the slides here are very brief. You can go and read about it. You can, there are a lot of if you prefer reading and learning things, that's also there. There are also a lot of videos around that you can use to learn about these topics. So definitely use this session to basically understand, like, what the end-to-end process looks like, what are the topics that we should focus on, but then you also would have to go back and read more about these topics. Yeah, so that's what it looks like. Uh, I There's one question where I would say is, I don't know anything about system design, but I'm interested in this. Should there be any prerequisite for this session? There is. Okay. Uh, I think there's no prerequisite for this session or any of these sessions. So we start. We are progressing in a sequential manner. So we're starting off with the very basic topics, and we will move to more advanced topics in towards the end of the session. So there is no prerequisite as such, but I would definitely recommend whatever topics we cover. Just this 45 to 1 hour session might not be sufficient for you to understand everything if you are seeing this for the first time. Let's say if you don't know anything about scalability, uh, this session might serve as a good starting point, but you have to also go back and read more about it so that you can be more prepared for the next session. Um, there's one question: how to ask requirement questions when they give design WhatsApp. I think we covered this. You should have your answer. Is this session intended for all level experienced? I would say as you grow, I think it definitely caters from a fresher to a few years of experience. As you grow up the ladder, you are more than, let's say, senior plus. That's when maybe you also need to dive even deeper into some of these topics. It totally depends on what level you are, but then this is a fundamental, basically. It's a good starting point that you should know irrespective of the level you are at. um, I think somebody asked, currently in third year, as it be beneficial to continue with this series. And can you please tell me for how many days these live streams are going on? Yeah, so it'll go on for 5 days. We covered first session today, and we'll have four more such sessions. Uh, so the agenda will have a live session scheduled again on YouTube, and that's how you'll get to know about the next sessions. But also it's this is the plan. We'll have four more sessions, and this is what the agenda will be. Um, is this going to be every day? No, it's not going to be every day. It will mostly be on Saturdays. Either we'll do it every Saturday or we might do it alternate Saturdays. And the timings are going to be same. So yeah, that's how it's going to look like. Any structured roadmap for system design? Um, I think my intention for this session is to basically provide you essentially a roadmap where you will have all the frameworks and all the starting points for any design interview. I might not be able to cover all of these topics in deep, but I will definitely list out all the topics. Let's say today's was a very light session, but in the next session, which is the high level, I might not be able to cover all the topics. So towards the end, I will list down what are the other high level topics that you should know, and you can go back and read about all of those topics. Um, Okay, what are the key metrics on which you are evaluated by the interviewer during the system design interview for someone with 2 to 4 years of experience? Um, so I think I mentioned a bit about this. So again, as in more experience that you have, you are expected to just have deeper knowledge of these things. So um, I haven't covered any of those like technical blocks. Let's say in the next session we'll talk about databases. So like a fresher or somebody who has lesser year of experience might know a certain things about database and relational and non-relational and how they work together, but somebody with more years of experience needs to know, dive deeper into that basically, and needs to know more about it. So that's how essentially for system design it's all about. The more years of experience you have, you need to have deeper understanding of the same topics. You don't essentially have a lot more topics added to the interview vocabulary. You just have to dive deeper and deeper. If somebody who is like a staff engineer, they would be reading a lot of so there are a lot of like research paper around all of these really popular large scale systems. So it's also a good habit, even if you're not somebody who's a senior or a senior plus engineer. It's good to build up a habit of reading all those research paper. Let's say a Facebook research paper, like what goes behind building like a large scale service. So it's also a good habit to read about and learn about those systems. um, so next session schedule, yeah, so it will be every Saturday same time. But at the moment, I think we are just figuring out if we want to do it every Saturday continuously, or do we want to do it like every alternate. We'll just decide that, and we'll schedule the session the same way we did this one, and you can check there and you will have the schedule. uh, will you be able to share the slides? I Let me see. I can add the slides in the description. I'll add that later. Yeah. So what are the basic topic one can pick up to start with? Yeah. So this what I'm doing is a good starting point. You can somebody who is just starting off can focus more on fundamentals and high level design, and once you are pretty thorough with that, then you can go towards more of low level and advanced topic. Um, is this only for SRE and DevOps? Um, this is for it is not essentially catering to particular niche as such. This is more towards a generalist role, which is generic software engineer. But yeah, like even in SRE and DevOps, you need to they also have a system design interview. It might cater to more of those specialized field. But this is something which is, even if you're an SRE or DevOps, you should know like basic things about the system design. Um, yeah, I think we have covered all the questions. Yeah, somebody mentioned please make it every Saturday. Yeah, we are just discussing that, and we'll figure that out. And yeah, hopefully we can make it every Saturday. Mm, yeah, I think I don't see any more questions. I might just wait for a minute, and if you have any more questions, feel free to ask me. Yeah, I think there are no more questions. I think I have answered most of them, if not all. Yeah, thank you everyone for attending. Hope it was helpful. Hope you got to learn some new things from this session, and hopefully you go back and read about the things that we studied today, because that will serve as a base for the coming session. So please make sure you do that after every session, and we will meet in the next session, hopefully next Saturday. Yeah, it should be the same time. Thank you, everyone.